All right, number 59 in 4.1 is asking us to come up with an approximation for 1 over the square root of 17. So these problems are not as different from the previous set of problems as you might think to look at it. The difference here is in this earlier batch, they gave you a function and they gave you an a value. Here, we have to come up with those two things on our own. But then we're still going to be using linearization to come up with the equation of a tangent line, and then we're going to stick that 17 back into that linear function to come up with this approximation here pretty soon. So, first thing we got to do, what's the function right here that models what it is that we are trying to evaluate here? And that function is going to be a 1 over the square root of some number, so we're going to make that a 1 over root x. Since we're eventually going to be differentiating that, it's probably a good idea to maybe rewrite that as x to the negative 1/2 power. The other thing we're going to have to do is come up with an a value here. And our a value needs to do two things. Number one, it needs to be close to this number right over here. And the second thing it needs to do is it needs to be easily evaluated in this f of x function that we just came up with. So I'm thinking you guys noticed this one pretty quickly. We're going to let a equal 16. It's only 1 away from 17, and it's a perfect square. So that's what we're going to use for our a value here. So at this point now, it becomes a problem just like in that earlier section right here. So we're going to need the value of f of a, which for us is going to be f of 16. So I'm going to put a 16 into this function right here, 1 over the square root of 16, and we're going to end up with 1/4. So that is our point of tangency, 16 1/4. And if you'd like to write that out, you can, just to have it in one spot right there. Okay, there's your point of tangency. Second part, much harder, is the equation of the tangent, the slope of the tangent line. So we need our derivative, f prime of x equals, and again, I'm going to look right here. That is going to give us a negative 1/2 x to the negative 3/2 power. That's not real pleasant. Maybe a better way to write that would be something like a negative 1 over 2. There's your negative 1/2. And now x to the negative 3/2 power, I'm just going to make that an x to the positive 3/2 on the bottom. Not great, but I'm not sure what else we could do with that other than radicals, and I don't know if that helps. So now we're going to evaluate that derivative, f prime, at our a value here of 16. So that's going to be a negative 1 over 2, and then we're going to take a 16 to the 3/2 power. So if you guys remember how to do that, any number to the 3/2 power, you're going to take the square root of that number first and then cube it. So that's going to be a 2 times, again, 16 to the 1/2 power is going to be a 4, but that's going to get cubed. So this is a negative 1 over 2 times. Let's see, 4 times 4 is 16, times another 4 is 64. So negative 1 over 128. And what we have right there, guys, is the slope of our tangent line. So we now have the point of tangency right here, the slope of the tangent. So now we're going to go to point-slope form, and we'll eventually solve that for y to get our linearization here. So this is going to be y minus your y-coordinate right here of 1/4 equals the slope of your tangent, negative 1 over 128, times x minus your a value right here, which is 16. Okay, so that's our equation right now of our tangent line in point-slope form, but we want it in slope-intercept. So I'm going to distribute that negative 1/128. Give me just a second here, guys. Let me make this so that I can scroll this a little bit better. Okay, there we go. And we're going to get a y minus 1/4 is equal to negative 1/128x. And I've got a plus now, negative times negative. And let's see, a 16 over 128. I think that's going to go in there 8 times if I'm not mistaken. So that should be a 1/8. Am I sure about that? 80 and 48. Yeah, that's right. And now we'll add that 1/4 on both sides right there. And I don't usually show this, but I'm going to here because what I'm actually going to add here is 2/8. Same thing as 1/4, but now I have my common denominator. So we're going to end up with y is equal to negative 1/128x and then plus a 3/8 at the end of all that. But instead of a y, because we're doing linearization, I'll go ahead and call that L of x. So where are we right now, guys? In the previous batch of problems, they wanted you to stop right there when you found the function. But here, they want us to approximate the value, what did we say, of 1 over the square root of 17. So here's the big kicker right here, guys, that if we wanted to find f of 17. That is really, really close to the value of L of 17. And that means we're going to plug a 17 into this expression right here. So that's going to get us, I'm just going to cut to the chase here, negative 1 times this 17 is going to be a negative 17 over 128, and then a plus 3/8. And I think I'm going to go to my calculator here to come up with an approximation for that. All right, so what did we have here, guys? Negative 17 divided by 128, and then a plus 3/8 at the end of all that. And I got this decimal value here. We're always rounding to two places, so I'm going to go 0.242. And that's going to be the answer that I put right here for this problem. But I think, since I'm already on the calculator right here, now's probably a good time to actually check this thing and find out how close we got. We were supposed to approximate the value of 1 over, there's my fraction right there, got it, the square root of 17. And if I were to hit Control Enter here, guys, which for me would look like that, that's the actual answer of this expression. So if I look at this answer right here and the previous one that we came up with above it, yeah, we can see that they're pretty darn close. In fact, they're accurate to the nearest, I guess to the nearest thousandth, they're off by 1, because that second one is 0.243, but they're really, really close. So I feel pretty good about that answer, and that's what we came up with then for problem number, I forgot what problem number it was, number 59. There you go, 0.242.